So thank you, Thomas, for joining us.
Thanks a lot, Nick, for having me. Hello, everyone. That's a very nice welcome. That's cool.
So the last the last day and this morning, people have been talking about alternative forms of AI emerging. People talking about the use of decentralization, the use of local resources to run models, democratization of all these methods. And so I think people would be curious to know, what do you think about the future of AI? What do you think about these trends? What are the things we should be sort of looking out for moving forward?
Yeah. It's a very good question. We've been thinking a lot about that at HuggingFace, and not only thinking but doing and shipping stuff since, I would say, about 18 months. And the tipping point for us was when people started, mostly to give credit, I think it was started mostly by this Microsoft Phi team, who kind of showed that you can have smaller models that actually have good performances. And so at this time, we were like, okay, that's very interesting, because we've been talking about, like hundreds of billion parameters and stargates, where you think, okay, these models have to be huge. But the reality is that there is a very likely future where you can have small models, and typically to put numbers, I would say between 2 and 10 billion parameters. 3 seems to be the optimal size right now. So small models that have a lot of what we need for context understanding. So they can maybe not solve the Riemann conjecture, maybe they cannot invent a new scientific discovery, but they can understand context, and they can have maybe enough intelligence to help us. And I was chatting, so I was in SF 2 weeks ago. I was having lunch with Andrej Karpathy, and we were playing around this idea of what he called the 1 billion parameters AGI, which is, he thinks, and I can agree, though I think 1 billion is maybe a bit small, but there might be small models that could really reach a very high level of intelligence in a way, if you pair them with tool for searching, for instance, if you pair them with tool for compensating for their limitation. And a lot of the limitation in these small models is around the capacity they have to remember a lot of data points. But we humans, we also use Google search, right? We don't need to remember all these data points. So there is, I think, a likely future where you can have these smaller models that actually are very powerful in a way. And the nice thing is when you start to focus on these smaller models, you can embed them in amazing things. So I was talking with a team, for instance, who is running a 3 billion parameters model on something that's kind of the size of my smartphone, like this, consuming 5 watts. So, if you push these trends in the future, there is a likely future where you can have like these small models almost everywhere, because they don't use a lot of energy. You pair them with the nice tool, they can be very, very powerful. So what at HuggingFace we've been doing around them there is mostly trying to open source the recipe to train well this type of model. So we have a range of models called small LM with O, small LM. We are currently training the version 3, which is very exciting for me, which will be a 3B model. And the idea is to kind of prove that this model can be as powerful as we think they can, and to open source all the recipe to train them and to deploy them on the edge everywhere.
And so what do you think the role of open versus closed source will be moving forward, particularly as industrial labs might start to be a bit more closed with their methods? Do you think that will act as a sort of a headwind to open source, or is there enough inertia, enough momentum outside an open source landscape to keep it going so well?
I think we'll have both cohabitating, basically. Just like we have closed and open source operating system, right? And it's not like one is better than the other. They mostly serve different purposes. So I think we always have kind of this frontier model that are mostly closed source, because, obviously when you're closed source, you kind of have an edge because you can copy everything which is open, but you can add things on top. So, if you're closed source and you're less good as someone who's fully open, there is a deep problem in how you're doing your research, right? You should just copy what they do. So we always have kind of this leading, very high intelligence frontier model. But I really believe there's a super big long tail of usage where the intelligence doesn't have to be as high, and basically where open source is going to shine, and where you can have all this very interesting approach where you do decentralized training, maybe, and you control the data, and maybe you do something, I don't know. You have a lot of things you can play around openness, around collaborative models in this long tail. And my point is this long tail is going to be a huge part of AI in the future. So you will use sometime the very big, GPT 4.5, but for many use cases you can explore with maybe a little bit less intelligence model, but then that have other advantages, be it like smaller, more efficient, or trained in another way, or maybe using some kind of data that you actually want to use, IP-free data, or I don't know.
Interesting. And then what are your thoughts on some of the emerging trends and training some of these models, like the use of reasoning, architectures like MOEs? What's your favorite emerging sort of like practice or architecture or technique that you think can really shift the needle in that direction?
Yeah, so I think reasoning is amazing, right? This is really the big shift at the beginning of 2025, and so there was obviously DeepSeek R1. That was really, I think, maybe a ChatGPT moment for open source model where people thought, oh, actually there is a range of models that are open, but the other big thing in R1 was all this like reasoning exploration and also distilling this reasoning in much smaller models that can actually learn to reason and applying this reasoning to many fields. So it feels again like it's a full kind of green field where there is a lot of low-hanging fruits. So for instance, at HuggingFace, we made a project called OpenR1, which we try to reproduce the DeepSeek recipe and to open source the remaining thing that they didn't open sourced, which was mostly around the data and a couple of things around the training recipes. And what we discovered is we actually get amazingly powerful models. So the last one we open sourced was 10 days ago, I think. It's called Olympic Coder. It's a model that's trained on Olympic coding challenges, some of them. And this one is better than 3.5, Sonnet 3.5, which is surprising because Anthropic is historically extremely good at coding models. So beating them on the coding challenge is interesting because it shows that basically with this reasoning approach, so that's how we train the model. We train it in a reasoning fashion on coding challenges. With this reasoning approach, you can actually really beat this first generation of model that was trained in non-reasoning way, and this in a way that actually even us, it's a team of 3 people at HuggingFace doing that, like 4. So a very small open source team can, again, kind of leapfrog this big lab. So yeah, I'm super bullish on reasoning. I think we will have a few months of exploring everything we can grab in this field. I think a lot of this model will start to be reasoning like we see already, right? Or have a little bit of reasoning. There will be a bit of a trade-off because obviously you don't always want to wait that your model has been reasoning for 20 seconds just because you said hi and the model is thinking how it should answer to this simple hi and how polite it should be or how maybe you're feeling today and how. So maybe for some question we don't want to do that, and the big trade-off will be, the big challenge will be, finding where to use or not reasoning. But I think this is a very big shift in how we train this model. The big shift associated to that is we'll move a bit of our compute budget from pre-training, which was huge, to post-training, which is where the reasoning happened. And this is kind of a change a bit in how we train this model. Regarding the architecture themselves, I don't think there is a lot of huge novelty. MOE seems to be now something that's generically adopted by more and more people, but that's quite a simple variant of transformers. So decentralized training is very exciting because we tried that a few years ago. Actually, there was a project we did. I was searching for a presentation I did 2 weeks ago.
It was a Petal?
Petal, yeah. We work with, we work at, it was New Rips 2021, so that's a bit old now. We did something called Training Transformers Together, where we invited people to train with us a model that was actually a DALI, a version of DALI. DALI 1 was a Transformers. And this was not really working at the time. And I kind of came out of these experiments, this training. We got best demo at New Rips, so that was nice. But I came out of this thing thinking, oh, this just doesn't work. Decentralized training for transformer doesn't work. But with the recent development like DLoco, all of this seems like it's really actually working. And even the big labs, I was talking to someone at Anthropic, they try this and it's actually working well. So there is like confirmation you can scale this decentralized training again. So that's very exciting. That's also a new thing for me in the past 3-4 months. And so Prime Intellect, for instance, trained this 10 billion model. We are proposing a new project called Boom, where we want to invite a couple of a big data center in Europe to gather their resource together. Maybe they don't have enough money to make a Stargate, but if we take these 3-4 maybe even 10 big data centers together, maybe we reach kind of a very large size as well. Maybe we can even extend that to having everyone training a model, so like everyone, just a little bit like SETI at home, everyone participating in a big training. So all of these things, and knowing that the algorithm now kind of work, make me very optimistic about this new trend as well.
Yeah, we've had quite a bit of discussion about this. Yesterday, there was an announcement between Varna and Flower with a model called Collective One, where we're trying to leverage 1.3 million users' data that they gather and they sort of selectively allow to be trained upon using data you can't normally get to. And so there's certainly so much activity, and it's going to really be a big unlock, I think, for these models. I think we should maybe open it up to the audience. So anyone who's a question, feel free. Oh, yes, the gentleman at the front. Mike's just coming.
Hey, Thomas. I recently read your article about, you discussed this idea of yes men on servers. And you talked about this idea of like AGI won't come from just scaling current models, and we need to have sort of a paradigm shift. Would you be able to comment on that?
Yeah, sure. It's a small blog I published that gets very unexpected attention for me. It was published in many newspapers in Europe and the US, and also I got a lot of emails of people commenting on this. So the general idea for those who haven't read it is I was sharing the personal story of me growing as a very good student, basically always getting very good grades, going to the top French university, then getting accepted at MIT and all this. And then when I became a PhD researcher, I discovered that I was actually a very average and pretty bad researcher. And I was extremely surprised. And around me, there was like old people who maybe were slightly less good at me than me at school, but that got really good ideas. And I was like, why can't I get good ideas? And my discovery, or at least my personal understanding, was that you don't really need to know the answer to be a good researcher, but you more need to know how to ask the good questions. And these are not exactly the same thing. Asking the good questions means when you see something, you ask a question that no one has thought about. And this question can be also as fundamental as Copernicus, reading everything from his time and everything saying basically the sun orbit the earth, and him thinking, actually, I think everyone's wrong, and that's the opposite. And these questions are very hard to ask because you need to be able to really say everything I've been taught is wrong. Or like it's like Einstein, writing maybe the speed of light is the constant, irregardless of how fast you're moving. The light will always move at 300,000 meters per second, which is something extremely counterintuitive even today. And I was very bad at asking this, and I think models are also very bad at this. Like they're very bad at challenging their own training data and thinking that the training data may be wrong. But if you want, and that's so my pieces was commenting an essay from Dario Amodei, the CEO of Anthropic, who was saying we're going to have like this country of Einstein in the data center, and I think a lot of people don't realize that the Einstein level of discovery is not just the linear extension of a good student, which is what we're building with, I think, with LLM. We're building basically what I was calling more like a country of yes men in the data center. So they're very good at doing, like they're very good students. They will know all the answer, all the expected answer, but they will find it very hard to challenge this. And if we want, the ultimate promise of AGI is like really like solving fundamental challenge. Like, can we go faster than light? Can we colonize galaxy, or like, can we solve cancer? And for some of these questions, you will have to challenge some of the things we know today, and you will have to say this is wrong. And so I think models are really bad at that. And one reason is, I think, the way we measure that is all of the benchmark for LLMs are all these question answering, where we ask a question, we know there is an answer, and the model has to know it. And even the most recent benchmark, like there is one called Humanity's Last Exam or Frontier Math, they're very tough questions, but we know there is an answer, and the model just has to write the answer. But the benchmark we should have is a benchmark where we ask the model to write the question. So yeah, that was mostly in a nutshell. I don't really have the answer, so I got a lot of emails with this is how we should build AGI. Some of them were interesting, so maybe I'll make a compilation at some point. A lot of them were a little bit crazy.
Any other questions? At the back there.
Hi. The past few years, the rage has been all about transformers, neural networks, and so on. In this current era, where do you see the role of theoretically backed old school classic machine learning?
It's a tough place to be nowadays. Yeah, there is not, right? It's so much of an empirical approach. That's the frustrating part about deep learning. I mean, I was really a theoretical physicist. You know, I did a PhD in quantum physics. So at first, I really came to deep learning because I love the math of loss functions, reminds me of free energy. But the day-to-day thing is not like that, right? You just like poke into your data and you try things and you have no idea, and you try things that you think are going to be wrong and actually they are better than what you think was supposed to be right. And this is very frustrating. So I don't have a very good answer for that. Yeah, I hope there is a couple of things though I think could be very nice in AI, and not a lot of people are studying there. It's around more like mechanistic interpretability, where we could try to understand a little bit more how the models are learning. I actually think there's a lot of probably statistical physics there, like the models are probably a little bit like following some phase changes. And I think that's where you may still have some beautiful math and understanding, but not a lot of people are really working on that at the moment, yeah.
Interesting. Yes, just in the corner there.
Hi, I'd be curious to hear your take on the discussions around AI safety and the regulations that may come with that on open source.
Yeah, there's a lot of things to say. I would say the overall thing, and maybe the most drastic direction, which is would AI become self-conscious and kill us all, which is the ultimate AI safety question, is a little bit related to my yes man thing, which is I don't think AI really has, this kind of creative potential to really escape and become. I think it's much more very useful assistant or very useful tool we are building. So I'm kind of aligned more with Yann LeCun type of thing. I don't think anyone would say today that it was very dangerous to open source Llama 3 because it free itself, or this type of thing, even Llama 4. So on this, but then there is a couple of very practical challenges, which is you don't want this tool to be really useful for bad thing. But it's kind of close to what we have with Google search, right? I don't think it would be very nice if you can search on Google for extremely dangerous, disease and how to make them, or like the blueprint of a nuclear power plant or this type of thing. So there is a type of information that should neither be on the internet nor in these models. So that yeah. For now, I think a lot of the open source model, and I would say that's probably the mainstream view, is that they're not very dangerous from safety point of view. I think at some point we should put them in the same test that we start to put in the frontier model, which is before we're allowed to release them. The most powerful, I'm talking maybe the DeepSeek V5. We should put them, in kind of a safety test. Actually, can you use that for bad thing already? It will be very tricky, right? I mean, DeepSeek is a good example, right? At China, how can we actually enforce rules there? And that's maybe one deeper question, which is, I'm not sure we'll be able to build kind of an international collaboration around that, and it's even more difficult now because our international collaboration structure are under heavy stress anyway. So, yeah.
Any?
Hi there. I can build up on this question around safety. Yesterday I asked a very similar one. So we are testing the models and technology, but we are not testing the people who are behind developing it, deploying, designing, and manipulating data. So what psychological or behavioral assessments do you have in place at HuggingFace, obviously, internally for your teams, and then externally for people that are using your platform?
Not so much. One reason is we don't train a lot of models. I was talking about these small models, but there is like 1.5 million models on the hub, and most of them are trained by external teams like Google, Meta. We don't have a lot of power on the team at Google, right? I cannot call them and say, hey, you should take a good look at your team behavior. So there is a limit to what we can do. What we try to do is more like nudging the community in the right direction, which is we try to put some good practices around documentation. For instance, we have this model cards, which we think is quite important, even if it looks, which explain how the model was trained. We have good practices that we try to list and to push forward, and we hope that this will inspire actually this team to do the same. I think it's doing that in some extent, like having your weights on the page where it's explained how the model was trained is much better than having them just on a Dropbox or a Google Drive, anonymous Google Drive, where you have no idea where it came from. Or having like Git versioning on the hub, you can actually even cryptographically verify your commits, so you can know actually who committed on this model from the first to the last thing. But then, yeah, it's a bit the same as the DeepSeek, right? There's a limit to the power we have as a platform on model builders just because they're independent entity and are, for almost all of them, actually bigger and more well-founded than us. Yeah. So it's more kind of a nudging.
I see. So I guess one last question. In the next 12 months, what's the most exciting thing you're expecting to see in AI?
In general?
In general.
A lot of things. I would say three big areas for me for 2025. One is very short term and happening already is around agentic AI. So giving to these agents some tools. There's a lot of reflection. There's a lot of knowledge around things we should not build as well. There was a paper by our team around what agents you should not build. But we also try to do education and to propose some libraries, not just to stay and say don't build anything, because it's also not very fruitful position, in my opinion. Agentic AI is happening. I think it's very interesting. The second thing is robotics. I'm very big on robotics. We have a growing team. We have around 10 people working on that. I think it's going to work this year. And the same, I think a lot of the robots that we see are, I would say, slightly scary, and they're not the robots I would like to see. So we try to propose kind of an open source, collaborative alternative to this, which I would love to see happening in the future. So we'll have a lot more news on this soon. There's already. And the last part I think is very interesting and kind of related. I think also what Flowers and all is doing is AI plus science. So basically using all the knowledge we now have on how to train this model to train models for science. So it could be weather forecasting, could be material discovery, could be protein prediction. We know a lot on how to train good predictive models, and they could be used for a lot of interesting application. So we're trying, mostly through collaboration, we're trying to help many teams on that. I mean, practically, for instance, right now we're training foundation models for material properties prediction, which I think is going to be very, very interesting to release and to see used by a community.
Great. Well, with that optimistic note, thank you so much for joining us today.
Thanks, Nick. Thanks, everyone.